Question 1. When considering the use of night setback strategies in a commercial office building's building automation system, BAS Jason, certified building operator, proposes reducing HVAC operation during unoccupied hours to save energy. However, he notices that the morning warm-up is failing to bring temperatures to set point in time for occupancy. What should Jason do to improve performance while maintaining energy savings? A. Disable the night setback function and run the system continuously to avoid complaints from occupants. B. Adjust the morning warm-up schedule earlier and tune PID loop parameters for faster response. C. Lower the night setback temperature even further to increase energy savings. D. Use manual overrides in the BAS each morning to force the system on. Answer. Correct answer. B. Explanation. Adjusting the warm-up schedule earlier and tuning the control loop, especially PID parameters, can improve thermal response and occupant comfort. Night setbacks are essential for energy savings per ASHRAE 90.1 guidelines, but performance requires coordination with pre-occupancy heating or cooling. Running the system continuously undermines energy efficiency goals. Lowering the setback temperature C could recovery further. Manual overrides D are not sustainable and introduce operational errors. Effective BAS use requires both automation and scheduled control logic. Question 2. To illustrate this point, consider school facility recently upgraded with new energy-efficient HVAC systems. During post-occupancy IAC evaluation, elevated CO levels were reported in several classrooms despite properly functioning ventilation fans. What is the most likely underlying issue? A. The CO sensors are not correctly calibrated, producing false readings. B. Demand-controlled ventilation (D/V) is limiting outdoor air below ASHRAE 62.1 requirements. C. The air filters are too restrictive and blocking return airflow. D. The economizer is operating during heating mode, reducing air exchange. Answer. Correct answer. B. Explanation. D/V strategies must still ensure compliance with minimum ventilation rate set in ASHRAE 62.1. If improperly configured, D/V can reduce outdoor air delivery, leading to elevated CO even if fans run. While sensor error is possible, it's less likely system-wide. Filters C affect pressure but not necessarily CO directly. Economizers D are typically disabled in heating mode. Sensor placement, control sequence, and minimum airflow settings are critical to indoor air quality compliance. Question 3. The core principles of electrical safety require full adherence to lockout-tagout (LOTO) protocols during HVAC equipment servicing. During a scheduled compressor replacement, Maria forgets to apply a personal lock but shuts off the disconnect switch. Another technician re-energizes the circuit, leading to an arc flash. Which violation contributed most directly to the incident? A. Failure to notify all personnel before restarting the equipment. B. Inadequate signage indicating maintenance in progress. C. Not applying a personal lock and verifying isolation per OSHA 29 CFR 1910.147. D. Choosing not to wear ARC-rated PPE while working. Answer. Correct answer. C. Explanation. The most critical error was not applying a personal lockout and verifying isolation, violating OSHA 1910.147. Group lockouts require each worker to apply their lock and test for zero energy, while PPE reduces injury severity. It doesn't prevent unexpected energization. Signage B is supplementary control, not substitute. Notification A is safe re-energization but doesn't replace lockout protocol. Personal locks are non-negotiable for electrical safety in HVAC maintenance. Question 4. Throughout the course of dehumidification in a commercial rooftop ULTU, an operator observes that the air temperature drops slightly, but relative humidity remains unacceptably high. What change in system operation would most effectively address latent load without overcooling the space? A. Reduce the evaporator coil temperature to increase total cooling capacity. B. Increase supply air volume to push more air across the coil. C. Introduce reheat using a hot gas bypass or electric coil after dehumidification. D. Switch to 100% outdoor air mode during peak humidity hours. Answer. Correct answer. C. Explanation. Reheat allows dehumidification without overcooling, addressing both latent and sensible loads. ASHRAE 90.1 allows reheat when necessary for humidity control, especially in systems without variable speed compressors. Lowering coil temp A can overcool space and cause comfort issues. Increasing airflow B reduces latent effectiveness. Using 100% outdoor air D may introduce more moisture unless outdoor air is dry. Latent load control requires understanding psychrometrics and system design interaction. Question 5. The underlying principle of effective water treatment in cooling towers is to prevent conditions that favor Legionella growth. James, a building operator, reduces biocide dosing frequency to cut costs. After several weeks, inspectors find biofilm buildup in the tower basin, which action would best align with industry standards. They increase blowdown frequency to flush contaminants more often. B. Resume a consistent biocide program per ASHRAE 188 guidelines. C. Install a light system at the basin outlet. D. Lower the tower's operating temperature below 7 type. Answer. Correct answer. B. Explanation. ASHRAE 188 requires proactive water management plans, including consistent biocide application to prevent Legionella. Biofilm is a known harbinger of bacterial growth and undermines system health. UVC helps with planktonic bacteria, but not biofilm. Lowering water temp D is impractical for tower operation. Blowdown A helps dilute minerals, but doesn't remove a step. Biofilm. Best practice mandates maintaining disinfectant residuals and documentation. Question 6. Examining the consequences of deferred maintenance, a 10-year-old variable air volume valve system begins showing signs of inconsistent temperature control across zones. Emily, the operator, realizes maintenance logs show inconsistent filter changes and damper inspections. What is the most likely root cause of the control issues? A. Faulty zone thermostats that require a calibration. B. Clogged filters and sticky dampers affecting airflow and feedback control. C. Leaks in the duct system reducing airflow to some zones. D. Improper balancing of air distribution at initial commissioning. Answer. Correct answer. B. Explanation. Inconsistent maintenance of filters and dampers leads to airflow disruption, causing feedback issues in valve systems. Preventive maintenance per ASHRAE 180 emphasizes maintaining airflow integrity. Thermostat issues are typically local, not widespread. Duct leaks C. Contribute, but are less likely if airflow was previously stable. Initial balancing issues D. Would have shown up sooner. Valve performance rely. Mechanical components and sensor accuracy maintained through routine inspections. Question 7. Despite the fact that a facility's condensing boiler meets thermal efficiency specs, the building operator, Mark, observes flue condensation staining walls and persistent acidic odor in the mechanical room. What is the most probable oversight? A. Improper flue slope causing condensate retention and backflow. B. Boiler is operating above design water temperature. C. Ventilation rate in the boiler room is too low. D. Expansion tank pressure is incorrect, causing surging. Answer. Correct answer. A. Explanation. Condensing boilers require sloped vent piping 1 foot or per foot to drain condensate safely. Staining and acidic odor suggests condensate is pooling or leaking, possibly corroding nearby surfaces. This is co-compliance issue under IMC 800 3.1. Operating temp B would reduce condensate, not increase it. Room ventilation C is important but wouldn't cause stains. Expansion tanks D relate to pressure but not flue gas issues. Flue design and materials must suit condensate producing appliances. Question 8. To careful analysis of a scroll compressor failure in a split system heat pump, the technician notes motor windings are charred and traces of acidic residue are present in the oil. Which event most likely triggered this failure? A. Low refrigerant charge causing excessive superheat and motor overheating. B. Frequent short cycling due to an undersized accumulator. C. Liquid slugging during startup from flooded evaporator. D. Power phase imbalance damaging the compressor windings. Answer. Correct answer. D. Explanation. Phase imbalance leads to overheating and insulation breakdown in compressor motors. Acid formation is a result of electrical failure. This is addressed under NEC Article 430 in manufacturer specs. Low charge A causes overheating but not acid. Slugging C causes mechanical damage, not electrical. Short cycling B stresses components but not electrical windings. Diagnosing failures requires both electrical and mechanical insight. Question 9. In response to rising energy costs, a facility manager asks Liam to implement energy-saving strategies across multiple AHAs. Liam considers disabling economizer operation on cool days. What is the most appropriate recommendation? A. Economizer operation should be enhanced, not disabled, to leverage free cooling. B. Economizers are only useful in heating mode and can be disabled. C. Night setback should be increased instead of using economizers. D. Increase fan speed to enhance air mixing and reduce runtime. Answer. Correct answer A. Explanation. Economizers offer free cooling by using outdoor air when conditions permit. ASHRAE 90.1 mandates economizer use in many climate zones. Disabling them increases energy use. They're not heating tools. B. A night setback. C. Complements, not replaces them. Higher fan speeds. D. May increase energy use. Best practice includes proper enthalpy sensors and control logic to optimize economizer use. Question 10. In a modern context of managing high-performance buildings, clear documentation is critical for diagnosing past events. A chiller trip during the weekend wasn't discovered until Monday, causing comfort complaints. How could better documentation have helped prevent the issue? A. Including detailed service logs in physical binders for future reference. B. Setting BAS alarms to notify operations staff via email or text. C. Assigning technician to stay on site during off hours. D. Installing CCTV in the mechanical room to capture events. Answer. Correct answer. B. Explanation. Modern BAS systems allow real-time alerts to operations staff. ASHRAE Guideline 13 recommends integrating monitoring with alerting. Logs A help in analysis but don't prevent delays. Off-hour staff. C is impractical for most operations. ECV. D is passive and unlikely to help proactively. Timely communication of faults is essential to minimize downtime and occupant discomfort. Question 11. To better understand system pressures, consider a technician servicing a medium temperature reaching cooler using our 448er. He measures a suction pressure of 28 sig at 35 dig box temp and suspects refrigerant issue. Subcooling is 10 dig and superheat is 2 dig. What is the most appropriate interpretation of these readings? A. The refrigerant charge is too high and is causing flooding of the evaporator. B. The expansion valve is stuck closed, starving the coil. C. The low superheat suggests overfeeding or 6V failure. D. The suction pressure is normal for the current evaporator temp. Answer. Correct answer. C. Explanation. Superheat near 0 dig typically means refrigerant is not fully evaporating before reaching the compressor, indicating overfeeding, or for E6V, overfeeding risks compressor damage. Subcooling is in normal range, and suction pressure aligns with R448. The PT charts for 35 dig for evap temp. Therefore A, B, and D are incorrect. EPA Section 608 and RE standards require evaluating all temperature-pressure relationships during diagnostics. Question 12. While examining a variable speed chilled water system, Tomas finds that several terminal units are not receiving adequate flow during peak load. The building uses a primary-secondary pumping arrangement with differential pressure sensors. What change will most likely correct the issue? A. Lower the set point of the differential pressure sensor to reduce bypass flow. B. Increase the primary pump speed to boost water flow to all branches. C. Adjust balancing valves on the secondary loop to favor distant coils. D. Relocate the DP sensor to a remote coil farthest from the pump. Answer. Correct answer. D. Explanation. DP sensors should be located across the most hydraulically remote coil to ensure pressure is maintained throughout the circuit. Placing the sensor too close to the pump results in under-delivery at far-end coils. Increasing primary speed. B. Only affects the primary loop. Lowering DP set point. A. Reduces flow. Adjusting balancing valves. C. Is reactive and inefficient. ASHRAE Guideline 22 emphasizes proper sensor placement for system control. Question 13. As a result of excessive indoor humidity complaints in a high-rise apartment ANA, the building operator reviews psychrometric data. The mixed air entering the coil is 78 dB, 67 dB, believing A is 55 dB and 54 dB. What is the dominant process occurring at the cooling coil? A. Sensible heat removal with no latent effect. B. Humidification due to air passing below dew point. C. Simultaneous removal of sensible and latent heat. D. Cooling below dew point causing overcooling. Answer. Correct answer. C. Explanation. A drop in W temperature from 67 deg to 54 deg indicates latent heat removal, moisture condensing. The dB drop shows sensible cooling. This mixed process is fundamental to dehumidification. ASHRAE Fundamentals Chapter 1 discusses psychrometric principles. Humidification B would ray be sensible only cooling. A would show constant WB overcooling. D isn't indicated unless reheat is used post-coil. Question 14. Across different scenarios, simultaneous low suction pressure and high superheat often indicate system issues. Greg, an operator, sees this condition on Wisahu with what is the most appropriate next step in diagnosing the issue? A. Add more refrigerant to compensate for low suction pressure. B. Check for moisture or debris restricting the TSV orifice. C. Reduce fan speed to allow for better heat transfer across the coil. D. Open the T6V superheat adjustment fully to increase flow. Answer. Correct answer. B. Explanation. A clogged TXV due to debris or frozen moisture restricts flow, resulting in high superheat and low suction pressure. Adding refrigerant A can lead to overcharge. Fan speed C affects heat exchange but not flow obstruction. Adjusting ESP D won't help if orifice is blocked. Epanorium guidance. Stress. Verifying flow pattern. Inspecting filter dryers when diagnosing flow restriction issues. Question 15. The implications of incorrect filter selection go beyond airflow. When a healthcare facility upgraded its filters from MERV 8 to MERV 14 without changing the fan motor or verifying static pressure, airflow dropped below design values. What is the most likely consequence? A. Decreased filtration efficiency due to bypass leakage. B. Increased particulate levels from outdoor air intake. C. System coil freezing due to reduced airflow and coil temp. D. Extended equipment lifespan from reduced fan operation. Answer. Correct answer. C. Explanation. Higher efficiency filters increase resistance. If fan capacity isn't adjusted, airflow drops. Low airflow across evaporator coils can drop surface temps below freezing, leading to coil freeze. MERV 14 filters should be paired with fan upgrades or pressure reset controls. A is incorrect unless filter frames are loose. B involves economizer or damper failure. D is false. Equipment strain increases with pressure drop. ASHRAE 52.2 provides filter rating guidance. Question 16. By comparing ERF systems to traditional split systems, one major advantage is simultaneous heating and cooling in different zones. Sarah installs a heat recover ERF in a multi-zone office. However, complaints arise in some zones not achieving set points. What could be the cause? A. Compressor failure in one of the outdoor units. B. Improper addressing or control logic errors in zone controllers. C. Excessive refrigerant charge preventing load balancing. D. Inadequate insulation on the suction line. Answer. Correct answer. B. Explanation. ERF systems rely on precise electronic communication between indoor units and the outdoor module. Improper addressing, control sequencing, or zoning configuration can prevent proper refrigerant flow management. ASHRAE 15 and manufacturer specs require commissioning verification. A. Would affect all zones. C. Might cause performance issues but not zone-specific failure. D. Affects efficiency, not zoning directly. Question 17. The growing trend in condensing gas appliances includes modulating combustion and sealed combustion chambers. During startup, a technician observes flame rollout in a sealed furnace. What is the most critical factor to investigate first? A. Inlet gas pressure below manufacturer's minimum rating. B. Blocked heat exchanger or flue causing backdraft. C. Dirty flame sensor preventing ignition. D. Faulty inducer fan motor drawing low current. Answer. Correct answer. B. Explanation. Flame rollout in sealed combustion furnaces usually means flue gases can't exit properly, often due to blocked heat exchangers or flue paths. This leads to dangerous combustion chamber overpressure, flame sensors. C. And inducer fans. D. Affect ignition but not rollout. Low inlet gas pressure reduces flame quality but not rollout risk. NFPA 54 and Inc. 300 3.3 Demand Flue Integrity and Combustion Safety. Question 18. In comparison with historical consumption of buildings, chilled water usage spikes every summer. John performs an energy audit and notices the cooling tower fans operate continuously. What measure would provide the most energy savings? A. Replace fan motors with ECMs for better efficiency. B. Disable the tower fans during nighttime operation. C. Add VVFDS to allow fan modulation based on condenser water temp. D. Reduce chilled water loop temperature to shorten compressor runtime. Answer. Correct answer. C. Explanation. Adding VVFDS allows tower fans to operate proportionally to load, saving substantial energy over constant speed fans. This aligns with ASHRAE 90.1 and DOE best practices. ECMs are more common in smaller systems. Disabling fans at night may increase condenser temps and reduce efficiency. Lowering chilled water temp increases compressor work. Fan control strategies are key in energy optimization for central plants. Question 19. The development of radiant cooling panels in high-performance buildings introduces new considerations. During a summer design review, NOAA specifies radiant ceiling panels in an office space with high internal loads. What factor most limits their effectiveness? A. The presence of suspended ceiling tiles above the panels. B. Poor insulation in the perimeter walls. C. High latent load from occupant activity. D. Cold water temperatures in the chilled water loop. Answer. Correct answer. C. Explanation. Radiant cooling is effective at removing sensible heat, but not latent. High humidity or internal moisture gains reduce panel effectiveness and risk condensation. Per ASHRAE 55 and 62.1, pairing radiant panels with dedicated outdoor air systems (DOAs) is common to control latent load. Cold water may cause condensation. Ceiling tiles affect air diffusers, not panels. Poor insulation affects load but not panel effectiveness directly. Question 20. The foundation of safe confined space entry in HVACR is hazard assessment. During a chiller tube cleaning in a large facility, 2 technicians enter a pit housing the evaporator. The space is not ventilated and access is via ladder. What is the correct procedural response? A. Proceed if no odor is detected and cleaning takes less than 15 minutes. B. Require forced air ventilation and continuous gas monitoring. C. Allow only 1 technician inside while the other supervises. D. Use full body harnesses and lifelines, but no ventilation is required. Answer. Correct answer. B. Explanation. Per OSHA 1910.146, confined spaces must be tested and ventilated before entry. Lack of natural ventilation, restricted access, and potential for hazardous gas buildup require forced air ventilation and gas monitoring. Presence of odor is not a safe indicator. Lifelines. D. Help rescue but don't remove hazards. Dual entry. C. Doesn't replace ventilation. All confined space protocols must be followed, regardless of time spent inside. Question 21. With respect to supply air design, a hotel retrofitted its fan coil unit FCUS from 2-pipe to 4-pipe systems to enable simultaneous heating and cooling. However, complaints soon arose about uneven temperatures and rapid cycling of units. What is the most likely cause? A. Improper insulation of the chilled water return line. B. Lack of a functional control sequence for seasonal changeover. C. Thermostats not properly programmed for modulating valve control. D. Incorrect fan speed settings for space conditions. Answer. Correct answer. C. Explanation. Thermostats that fail to properly modulate control valves lead to overshooting set points and rapid cycling. In 4-pipe FCU systems, modulating control maintains tight temperature regulation. If thermostats are configured for simple on-off control, performance degrades. Seasonal changeover. B. Applies to 2-pipe systems. Fan speed. D. Impacts airflow but not cycling directly. Insulation affects energy loss, not temperature control cycles. Refer to ASHRAE Guideline 36 for control best practices. Question 22. To determine whether a hydronic loop is properly balanced, Diego measures differential pressure across several terminal units in a heating system. He finds the pressure is much higher near the pump than at the end of the loop. What adjustment should be considered first? A. Reduce the pump motor speed to lower total system pressure. B. Throttle balancing valves at the beginning of the loop. C. Replace undersized piping at the farthest terminal unit. D. Increase water temperature to boost heat output. Answer. Correct answer. B. Explanation. Hydronic balancing ensures even flow by throttling flow at terminals closer to the pump. This helps redirect flow to far-end coils, reducing pump speed. It may worsen flow to distant terminals. Replacing piping. C. Is costly and unnecessary unless undersized. Water temperature. D. Affects heat delivery but not flow balancing. ASHRAE 90.1 and hydronic balancing guidelines recommend valve-based pressure balancing for efficient heat distribution. Question 23. Considering the evidence from building analytics, Amira notices that commercial buildings chiller short cycles during mild weather despite moderate indoor cooling demand. What optimization strategy would best reduce compressor wear while maintaining occupant comfort? A. Increase chilled water supply temperature setpoint during partial load periods. B. Decrease valve box minimum damper positions. C. Add additional insulation to ductwork in unconditioned spaces. D. Disable economizer operation during shoulder seasons. Answer. Correct answer. A. Explanation. Raising the chilled water setpoint during mild conditions allows the system to satisfy load with longer compressor cycles and reduced staging. It improves part load efficiency and matches cooling output to demand. Disabling economizers. D. Reduces free cooling opportunities, lowering damper minimums. B. May underventilate. Duct insulation. C. Reduces losses but doesn't address cycling. Refer to ASHRAE 90 and chiller part load performance strategies. Question 24. The correlation between effective HVAC scheduling and energy use is well known. A facility manager notices high energy use during off hours. Upon review, the building automation system BAS shows no active schedules for nights or weekends. What is the most appropriate corrective action? A. Set night temperature setbacks and adjust start-stop times in the BAS. B. Lower occupied temperature setpoints to reduce daytime energy use. C. Disable all air handlers after business hours manually. D. Upgrade the BAS to a newer software version. Answer. Correct answer. A. Explanation. Implementing proper start-stop schedules and temperature setbacks aligns system operation with occupancy, reducing unnecessary runtime. Manual control. C. Introduces inconsistency in human error, lowering setpoints. B. May save energy but does not address the off-hour usage. Upgrading software. D. Doesn't solve poor scheduling logic. ASHRAE Guideline 36 provides detailed guidance for optimal scheduling practices in BAS-controlled systems. Question 25. During the process of starting a large air handler, the motor trips on overload after a few seconds. Emma confirms that the starter is correctly sized and wiring is intact. What issue is most likely causing the motor to trip? A. Incorrect overload protection settings relative to motor flow. B. Insufficient belt tension on the supply fan drive system. C. A failed contactor coil intermittently dropping out. D. High ambient temperature in the motor control center. Answer. Correct answer. A. Explanation. Overload protection must be set according to the motor nameplate full load amps flow. If settings are too low, normal inrush or load current triggers nuisance trips. NEC Article 430 outlines these requirements. Loose belt. B. Reduce load, not increase it. A bad contactor coil. C. Would cause erratic starting, not overload trips. Ambient temperature. D. Impacts performance but rarely causes immediate tripping. Question 26. The most significant aspect of indoor air quality in energy-efficient buildings is balancing fresh air with energy use. After installing an energy recovery ventilator, Raj finds that humidity levels have increased in summer. What is the most likely reason? A. The ERV core is bypassing too much exhaust air. B. Return duct insulation is deteriorating. C. Outdoor air dew point is too high for the ERV to handle effectively. D. The building envelope is excessively tight. Answer. Correct answer. See explanation. In hot, humid climates, herbs cannot fully dehumidify incoming air if the outdoor dew point is too high. Supplemental dehumidification or dedicated dowers may be required. Tight envelopes reduce infiltration, not humidity from ventilation. Bypassed exhaust would reduce effectiveness but not directly cause humidity issues. Duct insulation affects heat gain, not moisture directly. Refer to ASHRAE 62.1 and 90.1 for ventilation humidity management. Question 27. By evaluating a refrigerant leak alarm in a machinery room, the building operator identifies an R134 leak at a chiller flange. What action must be taken immediately in accordance with safety protocols? A. Open mechanical room doors to exhaust refrigerant manually. B. Shut off ventilation to prevent refrigerant dispersion. C. Evacuate the area and activate the mechanical ventilation system. D. Turn off the chiller and monitor pressure drop until leak stops. Answer. Correct answer. C. Explanation. ASHRAE 15 and IMC 1105.3 require automatic mechanical ventilation to evacuate refrigerants from occupied spaces. R134 displaces oxygen and can cause asphyxiation in confined spaces. Manual exhaust A is too slow. Shutting off ventilation B worsens risk. Monitoring D delays mitigation. Immediate evacuation and activation of the fan system is the proper emergency procedure. Question 20. In what ways can pressure-temperature relationships help identify undercharging in a refrigeration system? Technician Brian observes a suction pressure of 40 sig with a coil temperature of 38 degv. Superheat is 25 degv. What does this suggest? A. Excessive refrigerant in the receiver. B. Overfeeding of the evaporator. C. Undercharged system with high superheat. D. Incorrect PT chart used during analysis. Answer. Correct answer. C. Explanation. High superheat with low suction pressure typically indicates insufficient refrigerant entering the evaporator. This leads to poor heat transfer and compressor overheating. PT charts for the correct refrigerant validate diagnosis. Overfeeding B causes low superheat. Excess refrigerant A would elevate suction pressure. Wrong chart D would produce inconsistent results, but the high superheat is the key indicator. Refer to EPA section 608 and standard PT principles. Question 29. One might argue that neglecting lubrication has minimal effect on HVAC systems. However, Javier finds that a belt-driven return fan emits a loud screeching noise and draws more current than normal. What is the best maintenance response? A. Tighten the belt and observe current draw. B. Shut down the unit and lubricate motor and bearing assemblies. C. Replace the motor to avoid unexpected failure. D. Increase airflow set point to compensate for reduced performance. Answer. Correct answer. B. Explanation. Improper lubrication increases friction, leading to noise, heat, and high amperage. Bearings and motor assemblies require scheduled maintenance per manufacturer specs. Tightening belts A. Won't fix bearing friction. Replacing the motor C. Is premature. Changing set points D. Doesn't resolve root cause. ASHRAE 180 outlines the importance of routine lubrication as part of preventive maintenance protocols. Question 30. In light of recent developments in refrigerant regulation, a new synthetic refrigerant blend is being used in place of R22. Marcus recovers refrigerant from a system and stores it in a cylinder labeled LA400 TINA. What potential EPA violation is he committing? A. Transporting refrigerant without a recovery license. B. Using a non-approved cylinder. C. Storing recovered refrigerant in a mislabeled container. D. Mixing flammable refrigerant with non-flammable refrigerant. Answer. Correct answer. C. Explanation. EPA 608 mandates accurate labeling of recovered refrigerants. Mislabeling creates safety risks and cross-contamination during reclaim. Recovery licenses are required but not the central issue here. Cylinder requirements B. Are important but not implied here. Mixing refrigerants D. Is prohibited but not described. The critical issue is accurate storage and labeling to comply with handling and disposal requirements.